Hello, everyone. My name is Peter, where I'm a statistician from the Department of Statistics, University of Ibadan. I'm a PhD student. Today, we are looking at polynomial regression. We've looked at the simple linear regression earlier on, and we have seen that we're able to predict outputs from input by just simply fitting a linear regression. However, in neuroscience and in many fields of science, the relationships are not always that linear. So it's possible through polynomial regression to fit all sorts of relationships. The idea of polynomial regression is in the non-linearity that exists in the independent variables, not necessarily in the parameters to be estimated. So the first thing that we need to recognize is that we have to do a plot to see how the scatter plot is so that we will know if the relationships are actually non-polynomial. Otherwise, there will be no need to use the polynomial regression. So what we do first is to estimate, to simulate some data. And very important to know that our random seed must be put there for the purpose of reproducibility. And then when we investigate our scatter plot, we see that the data points are not actually linear. Therefore, we can leverage on the strength of polynomial regression to model. The design matrix is the major hallmark of polynomial regression. So, and that's the key difference between linear regression and polynomial regression. The real difference is how we structure the input variables and also how our design matrix is made. So in the end, we will look at our coding exercise, which is exercise 2.1. We are trying to structure our design matrix. We create a function called make design matrix. And then as we try to run this code cell, we comment out this exception. And as we look at the broadcasting of the shape by creating a new statement, we create our design matrix, which is using the NP1's function. And at the end of the day, we're expected to get a for loop would range from 1 to the other plus 1 because we start from 0. And then we return the design matrix. However, we need to fit this portion, and typical of exercises, we are given hint here. So what we need to do is to call the NP numpy function, which in this case it is a stack, and we cast that into our design matrix because we previously created it. And because we are now doing a polynomial function, we raise our x to the power of our degree in this instance. And then when we run that cell, we will see our result. And at the end of the day, we have made a mistake. Oh, double. Okay, so there's an error there. So we have to cast it into a double parenthesis. And then when we run that, we have our results. You can see the output that they are consistent with what we have already. Thank you very much.